Welcome to this presentation on building cloud-native applications with GraalVM Enterprise, Micronaut, and Oracle Cloud. My name is Graham Roche. I am an architect at Oracle Labs, and I'm going to be taking you through these great technologies. So on the agenda for today, we'll do an introduction to Micronaut, we'll do an introduction to GraalVM, we'll do an introduction to Micronaut's integration with Oracle Cloud, and we'll do lots of demos. So as an introduction to Micronaut, Micronaut is a new Java application framework focused on the modern architectures like serverless and microservices. Much like Spring, it features dependency injection and aspect-oriented programming and those kind of features. So you can think of it as a complete application framework for any type of application, although the primary focus is microservices. It differs from other frameworks because it hooks into the Java compilation process through the use of annotation processes and computes everything to do with the framework's inner workings at build time in a completely reflection-free runtime proxy and dynamic class loader free manner. You can create applications today at Micronaut launch. Just head over to start.micronaut.io or micronaut.io/launch. And do find out more information on the website and the source repository on GitHub. So like I said, Micronaut is a complete framework, and at build time, it will analyze your application sources and compute all the dependency injection positions, all the annotation information, compute, for example, AOP proxies, like for things like @transactional, bean introspection, so that you can serialize and deserialize JSON without using reflection, and pretty much all other framework infrastructure in a completely reflection runtime proxy and dynamic class loader free manner. In terms of an introduction to GraalVM, GraalVM is a new virtual machine out of Oracle Labs that in JIT mode is able to increase application throughput between 20 and 30% and reduce latency. But it's also able to compile applications into self-contained native binaries, which is great for cloud deployments, command line applications, serverless applications, and many different use cases. It also features the Truffle language framework, which allows you to seamlessly interoperate multiple languages and libraries. And there are implementations of Truffle for things like JavaScript, Python, and Ruby. To find out more, head over to graalvm.org and check out the demos on GitHub for more information. Micronaut has a great relationship with GraalVM in that all of the work that Micronaut does at compilation time to eliminate the use of reflection, runtime proxies, bytecode generation, and so on, means there's less work for native images, the static analysis tool to perform. And it can basically analyze your code without much native image configuration itself and produce native binaries that start up ridiculously fast and reduce memory consumption dramatically. So Micronaut and GraalVM work great together, and at Oracle Labs, we develop them jointly. So do combine them to build amazing applications. Micronaut also has great integration with Oracle Cloud. So it will automatically, for example, detect Oracle Cloud environment and allow you to reconfigure your application based on running in Oracle Cloud or not. It features a Oracle Cloud module that allows you to inject your tenancy information and your authentication details and integrate the Oracle Cloud SDK, and supports building native images with the SDK. So do check out the documentation for Micronaut plus Oracle Cloud. And also check out the guides. We have great guides at micronaut.io/guides. Just search for Oracle, and there's lots of guides about using Micronaut with Oracle Cloud. So let's do a demo then of how Micronaut, GraalVM, and Oracle Cloud work well together. So I have over here Visual Studio Code set up with the GraalVM extensions for Java. And I'm going to create a new Micronaut project. So I'm going to start by clicking on this Create Micronaut Project button. And I'm going to choose the latest version of Micronaut. I'm going to choose Micronaut application. I'm going to use GraalVM EE, which is the latest release of GraalVM for Java 11. And I'm going to create a demo application and for Java. And I'm going to pick some features. So I'm going to pick our autonomous database integration with Oracle Database Server. And I'm going to pick JDBC. Okay, and those three, and I'm going to click OK. I'm going to use Graal as the build tool. We still have Maven as well, and JUnit as a testing framework. And what I'm going to do is I'm going to create in a location where I'm going to create my application, click Go, and create it there. And the application will be created in a new window. And I'm already up and running and ready to build applications, which is awesome. So I have my full IDE experience here. If we look at the source directory, we have an application class. And this is essentially the entry point for your application, where you can build your application. You also have a test directory where you can run tests, and a resource configuration. And you know that because I chose the autonomous database feature, I have already been set up and ready to connect to my autonomous database instance. Now, I've actually created an autonomous database instance ahead of time, and I can actually go and visualize that in my Oracle Cloud Oracle Cloud Infrastructure Explorer here. This is using the VS Code Oracle extension. And I have already, essentially created an autonomous database instance that I'm going to connect to. In addition to that, Micronaut encourages not, embedding passwords and so forth inside your configuration. So I've actually set up some environment variables already, which I can refer to from my my configuration here to allow me to connect up my autonomous database just by specifying the various environment variables that I want to resolve. So I have set up environment variables already locally with the OCID, the Oracle Cloud ID of my database, the wallet password, the username, and password from my schema user on the database. And with those things in place, I'm already ready to run my application. So I can click Run in continuous mode to start my application up, and it will connect up to my autonomous database instance. And I'm already ready to start building my application. So what I'm going to do now, the first thing I'm going to do is I'm going to create a new book entity. So I'm going to say new from template Java. I'm going to create a new book class. There it is. Okay. And I'm going to map this onto a table in the database. And the way you can do that is with mapped entity. So by annotating with mapped entity, I can basically map the book class onto the book table. And then I can go ahead and define some properties, right? So I can say private final long ID. And this can be my database ID. So I can say, or to make my database ID, I can say this is a generated value that is the ID of my database ID, and import those two annotations. And now that is my database ID. Now, when you first create an instance, you probably want to set the ID to null. So I'm going to make the ID nullable. And then I'm going to add another two properties here to my my entity called title, one called title and one called profile, author profile. There we go. So those are my three properties for my entity. And what you can do is I can generate a constructor that includes those three, and also generate some getters and setters. So what I'm going to do, I'm going to generate for all three of those different properties, my getters and setters. And now I have a database entity that is ready to essentially be mapped to a database table. So and my server will have automatically restarted. And so now how would I write a query to query the book table? So I've got this book entity that maps to the book table. So let's create a new from Java template again, and let's do an interface this time. And what we're going to call it is my book repository. There we go. And what I'm going to do is I'm going to make this a JDBC repository with a dialect of Oracle that extends from CRUD repository and supplies the book, that's the entity type, and the ID type, which is long. There we go. And with that in place now, I'm able to use the repository pattern to write queries and query the database. So I'm going to write now a controller that exposes this over HTTP. So I'm going to define a book controller, and we're going to expose this into the books endpoint like so. And we're going to dependency inject into my book controller the book repository. There we go. And what I'm going to do is I'm going to expose a endpoint that retrieves all of the books. So it's going to return a iterable of book like so, and we can call it list. And what we're going to do is we're going to say return book repository find all. There we go. Save that. And what we will find now is this will essentially, over the books URI, expose the data that of all the books in my application. The only thing is I don't actually have any books to start off with, so we probably want to create some. So I'm going to make my application class a singleton bean, and I'm actually going to inject my book repository into it like so, and add a constructor argument so that we can inject it. And then I'm going to add a method that's an event listener that is going to also be transactional, and it's going to run on when the application starts up. So we're going to listen for startup event like so, and we just need to import that startup event. And when the application starts up, what we're going to do is we're going to say repository stable list of like so, and probably we're going to have to import list like so. And what we're going to do is we're going to create a new book. Let's call it with a null ID called I don't know, understanding Micronaut. And for the profile image, we're just going to pass in some profile image. And then we're going to pass another book called Learning Micronaut. And again, we're going to pass in two different books like that. And probably we need a semicolon. Okay, so we've saved two books to the database when the application starts up. And we're exposing those books over a HTTP endpoint. So let's see what happens now when we head over to a browser and we hit the books endpoint. So let's go over here, go over to books, and there we go. So we have my two books being read from the Oracle Autonomous Database instance in Oracle Cloud, and it was all pretty simple. So now let's do something even more interesting, right? So let's expose another endpoint that allows us to return a optional book. And we're going to find, for example, a book by ID. Like so. Okay, so probably we need to import optional. And what you can do with Micronaut, like most frameworks that use annotations, you can bind a URI variable to the ID parameter, like so, and that will essentially inject the ID from the request into as a parameter and allow me to query books. So what I can do now is do return book repository find by ID and pass in the ID, and that will query for my ID. But what if I wanted to find books by title? So let's which is a method I don't actually have. So, and actually interesting, look at this type checking that we get here. So we get really nice type checking because I've changed the variable to title, but in fact that is not what my route declares, and that results in a compilation error from the framework. And that's one of the advantages of integrating with Java C in the way we do. We can surface those compilation errors. So I'm going to change this to find by title, like so, and then we can create a method, an equivalent method, and because Micronaut implements the repository pattern, this will just work, right? So this automatically gets implemented as a SQL query on the fly at compilation time, and my application, I'm able to implement a query like that. And we also allow integration with more with Oracle Cloud. So for example, we have a very strong integration with through the Micronaut Oracle Cloud project. You know, we have great documentation here on available modules. For example, one of those modules is the Oracle Object Storage SDK. So I'm going to add the Object Storage SDK to my build.gradle dependencies. And if you're using Maven, you do the same thing, just add a dependency on the Object Storage SDK. And now I can use Object Storage and Oracle Cloud SDK directly in my application. So without even having to change anything, all of the Oracle Cloud SDK is injectable. So for example, in my controller here, I can inject object storage like so, and the object storage object, and maybe I can just recreate my constructor. Generate constructor. There we go. I will have to add an import for object storage. There we go. Now, one other thing I should point out is that in both these cases, we're using blocking APIs. So Micronaut is by default based on Netty. So actually what you probably want to do is run all these operations on the IO thread pool, which essentially allows you to offload any kind of operations that would otherwise run on the event loop into the IO thread pool. So I'm going to, whoops, that's the wrong class. I'm going to implement make all of my operations run on the IO thread pool since they're blocking. So I've injected object storage, as you can see there. I'm going to write another endpoint here that takes the ID of the book and renders the author. And instead of returning JSON, this one is actually going to produce an image. So I'm going to say this is going to produce media type image JPEG. And I'm going to make it return a stream file and get author image. And we're going to take in the ID of the author like that, right? And what we're going to do is we're going to use the object storage client to get an object from object storage in Oracle Cloud. Now, in order to do that, we have to send a get object request, right? So this is going to be my request, and we have to build that up. So I'm going to say, before I do that, what I'm going to do is I'm going to use my repository to find a particular book by that ID and assign that to a local variable. So there's my book, and if the book does not equal null, then what I'm going to do is otherwise we're going to return null. So what happens when you return null in Micronaut is it results in a 404 automatically. So this will just result in a 404 error. And what I'm going to do now is from that book, I'm going to get the author profile image, which is the name of the object in object storage. And I'm going to use this object storage API to build up my get object request. So I'm going to say get object request equals get object request dot builder, and we're going to use a namespace name of cloud native devrel, which is my tenancy, and we're going to use a bucket name of my bucket, and we're going to use an object name, which is going to be the object name from my repository instance stored in the database, and we're going to build that into a request. Then we're going to say object storage, Oracle Cloud, give me an object, and obtain a response, right? Then from that response, we're going to say new stream file, and we're going to say response.get input stream, and we're going to say that this is a media type. It's going to be a JPEG type. There we go. And that is the logic that I can use to essentially pull a object from object storage in Oracle Cloud to my application response. And so if we switch over to the browser now, and we go back to my application, we refresh those books, it looks like it's not started up yet. So now it is. Okay, so I've got two books, one with in here, one with ID of 62, one with ID of 63. So what we can probably do, if the demo gods are with me today, is go to look at a particular author, and look, it's streamed myself. There's a picture of me in object storage from my Micronaut application, and it is pretty awesome that you can. It's so easy to essentially stream data from object storage through Micronaut, through its integration with Oracle Cloud, just through dependency injecting object storage in. Everything is configured, set up, wired together for me automatically from my local Oracle Cloud configuration. So you might be wondering how this works, in that I have the OCI CLI set up, and it's basically using my profile from the OCI CLI to authenticate and retrieve and do all the interaction with the Oracle Cloud SDK. When you later push to production, you will want to create a separate configuration under application-oracle-cloud.yaml that uses instance principals or whatever authentication mechanism you need to authenticate and retrieve, and Micronaut supports all those different authentication mechanisms. Okay, so once you're actually ready to build your application, you can do so. If I drop into and before I do that, I'm actually going to stop my application from running. So up here, so I'm going to stop my app. And you can build your application into a runnable jar file using GraalW assemble, and that will that you can then run with GraalVM which is the default VM virtual machine installed on Oracle Cloud. So I can go in here and I can see for like my Java version, I'm using GraalVM the latest version, and I can run java/build libs and run the application, and it will you can deploy that application to a VM, and more as you got everything set up regards to authentication and resource principals, it'll connect up to the database and start the application. Now notice that this application, if we look at I think we've changed the author IDs, but if we look at the books, you can see that the application is running on the JIT version, And if we go to another terminal window and just type JPS, you'll see that this is ID 2319191. And if we look at the activity monitor for Java in terms of memory usage, you can see that that virtual machine is, let me see, it was 23191. So 23191. So that's using 350 megabyte of memory, that particular virtual machine, Java virtual machine. However, if you build it into a native image, and I don't have time to build it into a native image as part of this demo, but what you can do is you can run Micronaut build native image, and it will build the application into a native image, or you can run GraalW native image and build it into a native image. And the startup time and resource consumption will significantly drop. So I actually have an application that was already built into a native image running here, and you can see when I run it, it's shaved, like a lot of the startup time is down to IO, but it's shaved 3 seconds of my startup time. And if we look at the memory consumption, you'll see that we have effectively halved the memory consumption through using native image, which is pretty impressive. So that's the demo. So want to find out more, you can head over to and take the Micronaut plus GraalVM plus Oracle Cloud for a spin with the official hands-on lab. Just jump to that link. You can check out Micronaut Moonshop, the official Micronaut plus GraalVM plus Oracle Cloud reference application, which provides lots of samples of doing different Oracle Cloud services. You can try all the Micronaut guides by going to Micronaut Oracle Cloud guides and searching for Oracle and heading over there. So lots of resources for. In addition, if you're looking for official documentation, the GraalVM documentation is available at graalvm.org/docs/introduction. Micronaut documentation is all available at docs.micronaut.io. And you can grab all the VS Code extensions that I used to demo this throughout the course of this demo from the Visual Studio Code marketplace. Just search for GraalVM tools for Java, install those, and get ready to be super productive with Micronaut plus GraalVM plus VS Code as demoed in this presentation. So then, in summary, Micronaut plus GraalVM plus Oracle Cloud provide an awesome combination to build cloud applications. Super productive, great tooling, and Oracle Cloud provides the performance and services that you need to build modern cloud applications. And Micronaut integrates superbly with the Oracle Cloud SDK, adding support for native image to it, and exposing it automatically to your application on demand. And you can deploy Micronaut to VMs directly or via Docker to container registry, and then go from Oracle Container Registry and then run Micronaut on Kubernetes or OKE, the official Kubernetes implementation on Oracle Cloud. So lots of possibilities opened up to building cloud applications with Micronaut and running them in a performant manner on GraalVM in Oracle Cloud. So thank you very much I hope you enjoyed this presentation and found out a whole lot of extra information about Micronaut and Oracle Cloud, and I hope you enjoyed the demo and enjoyed the rest of the conference and event. Thanks very much for your time.